my name is Casey Shivler and I'm doing a reassessment video on the Circuits 1 standard. I wanted to begin the video by correcting all of my mistakes because I clearly bombed this quiz. So let's see, the question states, the circuit shown in the diagram consists of two 1.5 volt batteries, two nichrome wires of different lengths and thicknesses. They give me the length and diameter of each wire. So what I did is, in order to get the area of each wire, I had to divide the diameter by 2, so then I do pi r squared, and it gives me my area. I have 0 equals EMF minus the electric field of the first one times L, minus the electric field of the second one times L2. So I then break it down to get this equation. I plugged in my values to solve for E1, and that gives me E1. As you can see, I'm using my area that I got up here. Then I can use E1 and just multiply by the area of the first one divided by the area of the second one to get E2. It then asks, what is the magnitude of conventional current flowing in the circuit? The mobility and the, electrons per cubic meter were given to me. So therefore, I can just plug into my equation I equals Q in A1 U E1 plus Q in A2 U E2. Normally, I is equal to Q in A V, but V is equal to U times E. So I just substituted into there. I then added up the currents for both, which gave me the total current. Then I moved on to problem 33, where it says to state which of the statements are true and which ones are false. So statements 1 through 5. The book made an error. It says that only statement 1 is true. However, both statement 1 and 5 are true. This is due because statement 1 states the drift speed of the electrons passing through location D, which is right here, is greater than the drift speed of electrons passing through B, which is true because I like to look at the current like the water flow. So if water flowing through a thin pipe is going to flow faster than water flowing through a thick pipe. Statement 5, that is actually true. It says the number of electrons passing location B each second is the same as the number of electrons passing D each second. That's actually a very important concept because the electron current is the same throughout the whole circuit. So therefore that is true and the book is wrong by stating that it's false. It then asks the radius of the thin wire is 0.22 millimeters and the radius of the thick wire is 0.5 millimeters. It gives me the mobile electrons per cubic meter right here, and then it gives me the mobility. And then it says if 6 times 10 to the 18th electrons pass location D each section, how many will pass through location B each section? Another reason that statement 5 is true and not false, the current of passing through D is going to be equal to the current passing through B, not necessarily the velocity, but the current is itself. It then asks, what is the magnitude of the electric field at location B? Well, since the current is the same for both, I can use the current passing through location D to plug in the I equals NA UE. A is equal to pi r squared, so I just convert my millimeters to meters and I plug everything in accordingly and solve for EB, and I get the magnitude of EB is equal to 0.26 volts per meter. Let's see. Woo. The second question, or the third question then asks, in a circuit with one battery connecting wires, it has a length of L and a compass deflection of 6 degrees was observed. It only has one battery in this circuit. Would you expect an increase or decrease in compass deflection in a circuit containing 2 batteries in a series, a length of 3L, and if it's made of the same wire but thicker? The thicker wire is double in the cross-sectional area than the thinner wire in the first circuit. What I concluded is I would expect a slight increase. It is known that the angle of deflection of a compass needle is given by theta equals arctan of the magnitude of the magnetic field of the wire over the earth. The magnetic field of a long wire is equal to mu naught over 2 pi I over r. I is also equal to V over R, which is the potential over resistance. Resistance is highly dependent on length and area. So if you're going to triple the length plus double the area, and on top of that, double the voltage, then yes, I would expect a slight increase in my angle theta. This concludes my video. Thank you.